Cotton is an important plant grown throughout the world due to its ability to produce cotton fibres. These cotton fibres that are essentially the plant's fruit are important to modern society as we use it to make many of our clothes, towels, sheets, etc. Growing cotton, however, can be quite challenging. Insect pests such as Heliocopervera, Armigra, the cotton bollworm, and Aphis gicipi, the cotton aphid, can significantly decrease the yields of cotton crops. To control these insect pests, Monsanto created a transgenic cotton species to produce its own insecticide, using the genes of the soil bacterium Bacillus thuringiensis, or BT, to produce a species-specific toxic protein which collapses the stomach of the cotton bollworm when it ingests it. This development means that cotton fields are less likely to be sprayed with a harmful insecticide such as a pyrethroid, which will enable small cotton ecosystems to keep its beneficial insects. For those of you who don't know what beneficial insects are, they are insects such as spiders, wasps, and mites that eat cotton insect pests such as the cotton bollworm and cotton aphids. Since BT cotton does not kill aphids, having beneficial insects in your cotton crop is a cheap, effective way to control aphids and other pests. The article I found on the Web of Science conducts experiments throughout 6 different provinces across northeastern China from 2001 to 2011 to determine whether BT cotton influences the number of beneficial insects in a cotton crop and whether these beneficial insects will lower the insect pest populations in comparison to conventional non-GM cotton. They collected results every 4 days throughout the cotton seasons, manually counting random squared meters for both predator and insects and aphids. This graph of the results obtained demonstrate that aphid populations per 100 plants have decreased by approximately 1,500 individual aphids from 1990 to 2010. The following graph shows that the increased predator abundance also lowers aphid populations in cotton fields, and in the final graph represents a non-GM cotton crop where pyrethroid insecticides were used to control insect pests, and also demonstrates to us that it lowers the beneficial insect populations. These results portray that GM crops such as cotton are able to manage cotton aphid as a pest more efficiently than conventional non-GM breeds. For instance, when conventional cotton is sprayed with a pyrethroid to kill insect pests, it also kills many predator insects. This then saw a greater abundance of the cotton aphid, as there were not enough predator species there to keep them under the ideal threshold when a fresh swarm of aphids enters the field.